Okay, it's equations. What are they? What is an equation? And how do we solve simple equations? A couple of things we'll talk about as quickly as we can. What's an equation? Equations are, it's a mysterious sounding name that sounds very grown up, and people tend to get a bit excited when they hear the word equations. They think they're being very grown up, and they are. But in actual fact, here's an equation that you've been able to do since you were about 4, I reckon. 2 plus 2 equals 4. There's an equation. Something on the left equals something of the right. Think of it as a set of scales that always balance. The left-hand side of the scales is balanced by what's on the right-hand side. They weigh the same thing. It's an equation. You've got an equal sign in the middle, and you have two sides that are equivalent or equal to each other. That's an equation. And here's another equation, getting a bit close to the sort of thing that once you hit the age of, I don't know, 11 or 12 or so, you're starting to learn to solve. But something else that you've done since you were, I don't know, 4, 5, 6. If I said I think of a number and add 5, and my answer is 6, what number did I think of to start off with? You all know the answer's 1, don't you? And sometimes you've seen it written like this, haven't you? Do you remember those questions you got when you were younger, where you had a box for you to write a number in? Something plus 5 equals 6, what I just said, and that box represents the number I first thought of, doesn't it? And when you were younger, you got used to writing numbers in like that, didn't you? To make the equation, make the sum, as you called it, make it correct or complete. And that's an equation too. Only these days, instead of having a box for a missing number, we give our missing number a name. And that's what equations are, is when you give unknown or uncertain values, you give them a name. And usually with equations, we give them the name we give them is a letter. And the famous one, of course, is x. And we draw our x, in England at least, in mathematics like so. I'll draw it again. You can think of it, I suppose, as a C and a backward C joined together like that. And in other words, it's an X with curvy legs, and it distinguishes it from that, which looks very much, doesn't it, like a time sign. And that's the reason why it's a good idea to write your X's as we have done here, so it doesn't get confused with the time sign. So here, we've got X plus 5 equals 6, and that X represents a number that we're not sure of. Okay, and we all know that X is equal to 1 here, don't we? Because we know that 1 plus 5 is 6. So let's just explain why by continuing the analogy of the scales. Imagine that we have a set of scales here, with a tray here and a tray here, and they're all balanced here, and they're balanced at the equal sign. The equal sign is like the pivots on these scales, and the left-hand side is equal to the right-hand side. So if we want to take something out of the left-hand side, then we have to take out the same thing from the right-hand side, and vice versa. If we take something out of one side of the scales, you always have to take the same thing out of the other side of the scales in order to keep those scales balanced. So in this situation here, we've got something plus 5 equals 6. To work out what that something is equal to, we need to take out that plus 5, don't we? And if we take 5 out of this side, there we go, then to keep the scales balanced, we'll have to take 5 out of this side of the scales as well, won't we? So if we take 5 away from the left, that's gone, and we've got X left. So there we go. And on the right-hand side, if we take 5 away from the 6 we had here, what have we got? 6 minus 5 gives us 1. And X equals 1, and that's an example of a simple equation solved. And we'll write it again. Here's another problem. I think of a number and add 6. My answer is 12. What number did I start with? Let's write that as an equation. I think of a number. Do we know what the number is at the moment? No, we don't. Let's give it a name. Let's call it X again. And I add 6, I said, so that's plus 6. My answer is 12, I said, didn't I? So that'll be equals 12. So there we go. There's our equation. X plus 6 equals 12, where X is the number that we first thought of. We don't know what it is yet. Right. So we want to end up, instead of saying X plus 6 equals 12, I want to end up by saying X equals something. So what have I got to get rid of from the left-hand side? Just leave myself with just X. That's right. I've got to get rid of that plus 6. How do you get rid of plus 6? By taking 6 away. And if you take 6 away from the left-hand side of the scales, you take it away from the right-hand side as well. So on the left-hand side, X plus 6, take away 6, leaves you just with X. And on the right-hand side, 12 minus 6 leaves you with 6. So the number I first thought of must be 6. Does that make sense? Yeah, it does, because imagine this was 6. 6 plus 6 does equal 12, so it's right. Okay, so here we're talking about numbers where taking a number, thinking of a number, and adding or subtracting something to it. Here's another one. Y minus 3 equals 15. The number I think of, take away 3, leaves me with 15. I want to know what the number was I first thought of, So I want to get rid of this minus 3. How do I get rid of minus 3? How do I turn it into nothing? By adding 3. Let's do that. If I add 3 on the left, I add 3 on the right. So on the left-hand side, I'm left with y. And on the right-hand side, 15 plus 3 is 18. Does the number you think of have to be a positive number? Not necessarily. How about this one? X plus 5 equals 2. I think of a number and add 5. My answer is 2. What number do I start with? Well, let's take 5 away from both sides. To get rid of the 5, which leaves me with x on the left, and on the right, it leaves me with 2 minus 5, which is negative 3, or minus 3. There we go. So x doesn't have to be a positive value. Similarly, x doesn't have to be on the right-hand side, on the left-hand side of the equation. It could be on the right-hand side. Same thing here. 13 equals x plus 5. I want to know what x equals, so I need to get rid of the plus 5. Get rid of it by taking away 5. 13 minus 5 is 8, so x equals 8. Exactly the same thing, it's just you've got x on the right instead of on the left, but it makes absolutely no difference which way round they are. 8 equals x is exactly the same as x equals 8. Okay, so that's a couple of simple equations where you start with a number, an unknown number, which we give a letter value. I've used x and y, but you could use a, b, c, d, any letter of the alphabet is fine. We add or subtract something to it. But of course it's possible, going back to earlier days at school, that the number you think of could be one that you multiply by something. So you might think of a number, it's called x, and times it by 3, say. Now if you take x and you have times it by 3, then you've got 3 lots of x, haven't you? And hopefully by now you've understood that 3 lots of x can be written as, we could write it as x times 3, couldn't we? Or we could write it as 3 times x, because those would both be correct. In actual fact, we've learnt now, haven't we, to write 3 lots of x as 3x. If I think of a number and times it by 3, I get an answer of 15, let's say. So what was the number I first thought of? Well, I've got 3 lots of x over here. And I want to know what 1 lot of x is. If I have 3 lots of x and I want to know what 1 lot of x is worth, then I'm going to take what 3 lots of x is worth and I'm going to divide it by 3, aren't I? And if I divide the left-hand side by 3, I have to divide the right-hand side by 3 as well. 3 divided by 3 is 1, so that gives me 1x. And on the right-hand side, 15 divided by 3 is 5. Let's do another one. Think of a number, times it by 7. My answer is 15. Okay, so I took a number, I times it by 7, I've got an answer of 15. So 7 lots of x is worth 15. So what do I do to 7x to make 1x? I divide it by 7. 7 divided by 7 is 1. So 7x divided by 7 is x. And over on the other side, I divide 15 by 7 as well. And always write it out like this because in this situation here where the number doesn't go exactly, it'll help you work out the correct answer. 15 divided by 7. It's a top-heavy fraction, isn't it, 15 over 7? How many 7s go into 15? 2 7s make 14, so I've got a remainder of 1. Write the remainder as a fraction over the number we're dividing by. There's your mixed number, there's your answer. X equals 2 and 1/7. There are some simple equations. In the first instance, we had some equations where we started with a number and we added or subtracted something to it. Here we added 5. Here we added 5 as well, actually, funnily enough. Here we subtracted 3 from our starting number, and we learned how to balance the scales and end up with an answer. And then subsequently, we learned what to do when we have multiples of x, multiples of an unknown number. Here we had 3 lots of it, we divided by 3 to get our answer. Here we had 7 lots of a number we started with, we divided that by 7 to get our answer, and the answer wasn't a whole number. Perfectly okay to leave your answer as a mixed number rather than as a decimal. That's perfectly mathematically sound. In the next video we'll look at how to solve equations that have both of those things, and then we have multiples of x as well as something added or subtracted to or from the missing number or the starting number.